Hello, I am Aristotle F. Barcelita and I'm going to discuss about electrical engineering second sem. First, I'm going to discuss about electric charge and electric current. Electric charge. An electric charge is a physical property of matter that causes it to experience a force when placed in an electromagnetic field. There are two types of electric charge, positive and negative. The positively charged matter are driven away from other positively charged matter. However, there are attracted to negatively charged matter. Itong electric charges, nakaka-experience to ng force when placed into electromagnetic field. Yung two types nga nito ay ang positively charged and negatively charged. Electric current. An electric current is the flow of electric charge. This charge is usually carried moving electrons through a wire. In the case of electric circuit, it can also be carried by ions in an electrolyte or both ions and electrons such as in a plasma. Ito naman yung mga flow ng electric charge. Yung mga charges na yon ay dumadaloy through a wire. Pwede rin naman siyang i-carry ng mga ions in an electrolytes or both ions or electrolytes and electrolytes. So dito naman, ito naman yung some conversions in electric charge and electric current. 1 electron is equal to 1.6 times 10 raised to negative 19. Yung 1 coulomb naman is equal to 6.24 times 10 raised to 18. Note, when 1 coulomb of electric charge continuously passes in a given point per second, the electric current is said to be 1 ampere. Therefore, the 1 ampere is equal to 1 coulomb per second. And 1 ampere is equal to 6.24 times 10 raised to 18 electron per second. Roughly, 1 ampere is equal to 6 billion electrons passing to a certain point per second. Next naman yung pagkuha ng current. Ang formula sa pagkuha ng current is I is equal to Q over T, where current is denoted as I and the unit is ampere, denoted as A naman siya. Q is the charge and the unit is coulomb, denoted as C. And T is the time, unit naman niya is second, denoted as S naman siya. So we have sample problem here about electric current. A current of 0.75 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So in this given problem, the given are the current which is equal to 0.75 amperes and the time is 10 minutes. Ang gagawin natin, we have to convert it into seconds. Alam naman natin na isang minuto ay equal to 60 seconds. So, when we convert 10 minutes to 60 seconds, this will be 10 minutes times to 60 seconds. The time is now equal to 600 seconds. So, we're going to find the amount of electric charge that flow through the circuit, which is denoted by Q. To solve for that, the formula na gagamitin natin is Q is equal to L times T, which is from the formula natin na I is equal to Q over T. So, ang gagawin lang natin, directly substitute lang natin yung given value sa formula. So, magiging ganito siya. Q is equal to 0.75 ampere times 600 seconds. Tapos ang makukuha nating sagot sa kanya pagka pinag-multiply lang natin sila is 450 coulombs. Therefore, the amount of electric charge that flows through the circuit is 450 coulombs. So next is electron drift velocity. This is the average velocity attained by charged particles such as electrons in a material due to an electric field. Ito lang yung average velocity na na-attain ng charged particles So we have here its formula. BD is equal to I over N times E times A, where BD is the electron velocity. The possible units are inches over second, centimeter over second, and meter over second. Yung I naman, yung nasabi ko naman na kanina, yung current, yung current natin. At ang unit niya is ampere, denoted siya as A. And yung N naman natin is the free electron density. The units are E, M cube, and E over inches cube. Yung E naman is the charge of electron. Yung unit naman niya is C over E, which is equal to 1.6 times x raised to negative 19. And yung A is the cross-sectional area. Yung units naman niya ay m squared and inches squared. So here is the dimensional analysis of electron drift velocity. This only explains the cancellation of units, which yields to meter over second, the unit of electron drift velocity. So we have here an sample problem of electron drift velocity. Sa problem natin, calculate the drift velocity of electrons in a cylindrical copper wire with a radius of 1 mm or 0.01 meter, carrying a 15 ampere current, given that for copper, N is equal to 8.342 times 1028 E all over M cube. Yung given natin are I, which is the current, is equal to 15 amperes, and or for the electron density is equal to 8.342 times 10 raised to 28 E all over M cube. Yung E or the charge of electron, which is equal to 1.6 times 10 raised to negative 19, at yung R naman natin, which is the radius, equal naman siya sa 1 mm or 0.001 meter. So yung formula natin na gagamitin para ma-solve yung electron drift velocity, yung formula lang na sinabi ko kanina. Yung BD is equal to I over NEA. Since wala pa tayong area, kailangan natin siyang isolve using the given radius. So the area A of the cross section of the wire is pi r squared, or pi times 0.001 squared. Ngayon, pag kinalculate natin siya, nag-i-equal siya sa 3.14 10 raised to negative 6 m squared. So lahat nakuha na natin yung given value para ma-solve yung problem. Kailangan na natin i-substitute siya directly to the formula. So pag na-substitute na natin siya sa ating formula, makukuha natin sagot dyan is negative 3.6 times 10 raised to negative 4 meter per second. So negative yung nakuha nating sagot. The negative sign indicates that the direction is against the current flow as expected for electron, kasi ang alam naman natin ang electron ay negative siya. So in here is an electron density table. We have some elements such as aluminum, barium, copper, gold, iron, and silver. This table tells us the conduction band electron density and free electron model Fermi energy of the given elements on the table. So, in this table is the electrical hazard to humans. So, pinapakita lang dito yung epekto ng current sa tao. Una is 1 milliampere. Yung epekto nito is barely perceptible o hindi gaanong halata yung epekto. Pangalawa natin is 1 to 3 milliampere. Perception resolved most cases. Kumbaga, parang wala lang, ganun lang sa una, ground lang, ganun. Sa 3 to 9 milliampere naman, painful sensation, ibig sabihin makakaramdam na ng sakit. Yung 9 to 25 milliampere, muscular construction. So dito naman mga muscle nagko-construct or lumiliit. 25 to 60 milliampere, respiratory paralysis. Probably fatal siya. Dito naman yung epekto nito is nakakamatay na siya kasi ang natatarget niya is yung respiratory natin, which is nagkakos siya ng paghirap ng huminga na naglilid sa pagkamatay. Yung 60 milliampere or more, ventricular fibrillation, probably fatal din siya. Nagkakaroon ito ng epekto, nagkakos siya ng abnormal na rhythm sa puso natin, which is nagkakos din ng pagkamatay. Yung 5 ampere or more, dito naman heart paralysis na. Malala na siya dahil direkta na talaga sa puso yung tama niya. Ng sanhi ng pagkamatay. Yung 5 ampere or more, tissue burning, fatal if vital organ. Ito naman yung pinakagrabe. Nasusunog na yung mga tissues natin. Ang ano lang dito, na mahalagang malaman natin yung electrical hazard for us to be aware of these effects to us para maiwasan din natin yung mga ganitong pangyayari. Our next topic is electrical wire and standards. So, American wire gauge, or also known as the Brown and Sharp wire gauge. American wire gauge, denoted as AWG, also known as the Brown and Sharp wire gauge, is a logarithmic step standardized wire gauge system used since 1857, predominantly in North America, for the diameters of round, solid, non-porous, electrically conducting wire. Dimensions of the wires are given in ASTM Standard B 158. The cross-sectional area of each gauge is an important factor for determining its current carrying capacity. The AWG tables are for single, solid, and round conductor. The AWG of stranded wire is determined by cross-sectional area of the equivalent solid conductor. Because there are small gaps between the strands, a stranded wire will always have slightly larger overall diameter than a solid wire with the same AWG. AWGG is also commonly used to specify body piercing jewelry sizes, especially smaller sizes, even when the material is non-metallic. So, based on the definition, ang American wire gauge ay mas kilala sa tawag na Brown and Sharp wire gauge na nag-start itong gamitin noong 1857 sa North America para sa pag-conduct ng electricity through this wire. So, ang example ng AWG natin ngayon na ginagamit ay makikita natin sa mga nakakabit sa DVD player natin at sa mga PlayStation. Maganda itong conductor ng electricity kasi cross-sectional siya, which means solid wire lang siya, mas madali siyang daluyan ng electricity at mas mababa ang resistance niya. Rules of thumb. The 6th power of 39 square root of 92 is very close to 2, which lead to the following rules of thumb. When the cross-sectional area of the wire is doubled, the AWG is decreases by 3. Sample 2 number 14 AWG wire have double about the same cross-sectional area as a single number 11 AWG wire. This doubles the conductance. When the diameter of the wire is doubled, the AWG decreases by 6. Example number 2. AWG is about twice the diameter of number 8 AWG. This quadruples the cross-sectional area and conductance. A decrease of 10 gauge numbers, for example from number 12 to number 2, multiples the area and weight by approximately 10 and reduces electrical resistance and increases the conductance by a factor of approximately 10. Find the same cross-section. Aluminum wire has a conductivity of approximately 61% of copper. So an aluminum wire has nearly the same resistance as copper wire, smaller by 2 AWG sizes, which has 62.9% of the area. A solid round 18 AWG wire is about 1 mm in diameter. So, di ko na siya masyadong elaborate si rules of thumb, pero mostly ginagamit siya for early stages of design such as briefing and concept designs. So, eto naman yung mga American wire gauge conversion units. So, dito naman, naka-table na siya para mas madaling mahanap yung conversion unit na kailangan para sa pagkuha ng current or voltage. IEC 60228 is the International Electrotechnical Commission International Standard on Conductors of Insulated Cables. As of 2020, the current version is 3rd edition 2004-11. Among other things, it defines as a set of standard wire cross-sectional areas. This international standard specifies the nominal cross-sectional areas in the range of 0.5 mm squared to 2,500 mm squared for conductors in electric power cables and cords of the wide range of types. Requirements for number and sizes of wire and resistance values are also included. These conductors included solid and stranded copper, aluminum, and aluminum alloy conductors in cables for fixed installation and flexible copper conductors. So based sa International Electrotechnical Commission, ang standard na ginagamit ngayon for cables and cords is 0.5 mm squared to 2,500 mm squared, which means ito na yung mga size na pinakamagandang daluyan ng kuryente or mag-conduct ng electricity na magre-range sa size na to. And yun nga, copper ang ginagamit kasi pangalawa ito sa best conductor ng electricity, pero silver ang number 1 na best conductor ng electricity, pero dahil expensive siya, hindi siya convenient gamitin. So dito, as we can see, walang lumampas na haba or ikli mula 0.5 mm squared to 2,500 mm squared kasi ito na ang standard na ginagamit internationally. Stranded wire and solid wire. Stranded wire pro. The bundled braids of stranded cable offer a few acute benefits over solid wire, like flexible, malleable, will not split or severe. Stranded wires application. Stranded wires are more suited to indoor applications, where bending and twisting are necessary to connect electronic components like circuit boards, speaker wires, electromechanical assemblies, and assemblies. So, ang stranded wire daw ay flexible, malleable, and will not split or severe, which mean pwedeng mabanat pero di siya pwedeng i-divide or hatiin. Sa application naman niya or sa paggamit sa kanya, mas maganda siyang gamitin indoor or sa mga bahay. Kasi flexible siya at mas mataas ang resistance niya. Solid wire pros: weather resistant, anti-corrosive, low cost. Yung solid wire application naman, solid wires are more suited for outdoor or heavy-duty application where higher current and more rigid durability are required. Building infrastructures, vehicles controls outdoor application. So di kagaya ng stranded wire, ang solid wire naman di siya ganun ka-flexible kasi nga solid yung mga wires niya. Pero mas mura siyang gamitin kaysa sa stranded wires dahil mas madali siyang daluyan ng kuryente. Mas mababa yung resistance niya. Sa application naman niya, mas maganda siya gamitin sa mga labas or sa mga poste kasi anti-corrosive siya, which means inhibiting or kaya niya i-prevent yung corrosion or pagsabog dahil nga sa solid siya. Resistance and resistivity. Resistance and resistivity. So here, pinapakita lang dito sa table yung comparison ng resistance and resistivity. Stated that resistance is the property of substance due to which it opposes the flow of electrons, while yung resistivity, it is defined as the resistance of material having a specific dimensions. Then yung formula naman ng resistance is R is equal to P times L all over A, while yung sa resistivity is P is equal to R times A all over L. So, etong sa resistivity, from the formula of resistance lang to. Manipulated lang siya. The unit of resistance is ohms, while the resistivity is ohmmeter. R naman yung symbol ng for resistance, and P naman yung for resistivity. So, this slide naman, ito naman yung formula sa pagkuha ng resistance. Yung R is equal to P times L all over A, where R is the resistance nga, ng unit nga niya ay ohms, yung P naman is resistivity, at ang unit naman niya ay ohmmeter, and circular milliohm per foot. Yung L nga is length, yung unit niya ay meter and foot. Yung NA naman is the cross-sectional area. Yung unit naman niya ay m squared and inches squared. We also have here the formula for the area circular mills, which is A is equal to D squared. Where A naman is the area in centimeter, D is the diameter in mils. Note that 1 inch is equivalent to 1,000 mils. So, ito yung mga resistivity value ng mga elements. Yung mga equivalent value niya ay makikita dyan. Magagamit siya sa pagkuha natin ng resistance at voltage ng mga circuits natin, like parallel and series. Temperature effects in resistance. Material that are classed as conductors tend to increase their resistance with an increase in temperature. Insulator, however, are liable to decrease their resistance with an increase in temperature. Material used for practical insulators are glass, plastic, etc. Only exhibit a marked drop in their resistance of a very high temperature. They remain good insulator over all temperature they are likely to encounter in use. The higher the temperature, the more likely violently the atoms vibrate. In a conductor which already has a large number of free electrons flowing through it, the vibration of the atom causes many collisions between the free electrons and the captive electrons. In an insulator, however, there is slightly different situation. There are so few free electrons that hardly any current can flow. All the electrons are tightly bound within their particular atom. So, ibig sabihin sa slide na binasa ko na nakakaapekto din yung temperature sa pagdaloy ng kuryente, which is pag mataas daw ang temperature ng conductor, mas mataas din daw ang resistance niya. However, kabaliktaran naman sa insulator na pag mababa ang temperature, mataas naman ang resistance niya. Impaired absolute temperature is the temperature at which a system is in a state of lowest possible minimum energy. As molecules approach this temperature, their movements drop toward zero. It is the lowest temperature a gas thermometer can measure. No electronic device works at this temperature. This kinetic energy of the molecules become negligible or zero. So sa impaired absolute temperature naman, para siyang law of entropy ng thermodynamics na absolute zero, which means ito na yung pinaka lowest point na hindi nagagana kahit anong energy or electricity na ma-attain natin. So meron tayong formula dito regarding sa temperature effect of resistance. Formula natin is R2 is equal to R1 times 1 plus alpha delta T, where R2 is the final resistance. Ang unit niya ay ohms. Ganun din yung R1, pero siya ay initial resistance. Yung alpha naman natin is the temperature coefficient of resistance. The unit is degrees Celsius raised to negative 1. This is also equal to 1 over absolute value of T plus T1. Absolute value of T is the impaired absolute zero. The unit is in degrees. Delta T in delta T naman natin is change in temperature. Degrees Celsius is also the unit. This can be solved with the formula T2 minus T1, wherein T2 is the final temperature, yung unit niya is degrees Celsius. Yung T1 naman niya is initial temperature, yung unit din niya ay degrees Celsius. When solving for R1 or other values, we're just going to rely with the formula. We just have to manipulate the formula to solve for the value that we need to identify. Temperature effect on resistance. So dito, mga temperature na pag na-attain ng mga given elements natin ay maapektuhan na siya sa pagdaloy ng kuryente. Ito lang yung guide para malaman natin kung hanggang saang temperature ang kailangan natin sa pag-conduct ng electricity, kung hanggang saan magandang mag-conduct ng electricity at sa temperatura nito. Meron tayong example dito on how to solve for the final resistance. If the resistance of copper wire is 50 ohms at 20 degrees Celsius, what is the resistance at 100 degrees Celsius? Boiling point of water. Obviously, the given are 50 ohms is the initial resistance niya. Yung initial temperature naman na given doon is 20 degrees Celsius. At yung final temperature na given is 100 degrees Celsius, which is the boiling point of water. It is also stated in the problem that the elements we are solving is the copper wire. So since meron tayong table kung saan malalaman yung temperature effect on resistance, makikita doon na yung copper is negative 234.5 degrees Celsius siya. So dahil nga absolute value yung nasa formula, hindi na natin isasama yung negative sign. So isa-substitute lang ulit natin siya sa formula natin. And makukuha natin yung sagot. So pagka sinolve natin siya at kinompute, yung final resistance natin ay mag-i-equal siya sa 65.72 ohms. Electric circuit. Path for transmitting electric current. An electric circuit includes a device that gives energy to the charged particle, constituting the current such as the battery or a generator. Device that use currents such as lamps, electric motors, or computers. And the connecting wires or transmission lines. Two of the basic laws that mathematically describe the performance of electric circuits are Ohm's law and Kirchhoff rules. So, etong electric circuit, ito yung nagsisilbing path o daan para sa pag-transmit ng electric current. Meron ding mga devices na nagbibigay ng energy, mga charged particles. Isa nga dito yung battery or generator. May dalawang basic laws. Itong electric circuit, the Ohm's law, and Kirchhoff rules. Ohm's law. Ohm's law is the most fundamental formula for simple electric circuit. It states that electric current passing through a conductor is directly proportional to the potential difference across the conductor. It was first formulated in 1827 by German physicist George Ohm while doing experiments on how well metals conducted electricity. Ohm's law is the best demonstrated in a simple DC electric circuit. Although it also applies to AC circuits, care must be taken to account for other possible variables. Ohm's law shows the relation between voltage, current, and resistance in a simple electric circuit. The easiest form of equation is B is equal to I times R, where B is the voltage in volts, denoted as B. Yung I naman is current in amperes, or denoted as A. Yung R is the resistance in ohms. Yung ano niya, denoted siya ng pag ganito, yung ohms. So, ito lang yung simple equation para sa pagkuha ng volts, current, at resistance ng isang circuit. So, we have here example. Una, find voltage. If you know current and resistance, you can find voltage from B is equal to I times R from the formula na sinabi ko kanina. For example, if the current is equal to 0.2 ampere and the resistance is equal to 1000 ohms, pagka nilagay natin siya sa may formula natin, magiging ganito siya. B is equal to 0.2 ampere multiplied by 1000 ohms. Makukuha natin yung voltage from that. At ang makukuha nating sagot is 200 volts. Next naman na hanapin natin yung current. Yung if you know voltage and resistance ulit, you can use algebra to change the equation. So, manipulation lang to. magiging ganito siya. I is equal to B all over R. Para mahanap natin yung current. For example, if B is equal to 110 volts and R is equal to 22,000 ohms, then pagka nilagay natin siya sa may formula, nilapat natin, magiging ganito siya. I is equal to 110 volts all over 22,000 ohms. Ngayon, pag na-compute natin siya, makukuha natin sagot ay magiging 0.005 ampere yung current nung hinahanap natin. Yung last natin, finding the resistance. Yung if you know voltage and current, you can use ulit yung simple manipulation natin, yung algebra. Ang magiging formula natin para makuha yung resistance is R is equal to B all over I. So, sa problem natin, if B is equal to 120 volts and I is equal to 5 ampere, then R is equal to 200. Then yung magiging formula natin ay magiging yung R is equal to B all over I. Pag nilapat natin siya sa formula, magiging R is equal to 220 volts over 5 ampere. So, ang makukuha nating sagot mula sa equation na ginawa natin ay 44 ohms. Yun yung resistance ng problem. So, next topic natin is series and parallel circuit. So, a series circuit is a circuit in which resistors are arranged in a chain. So, the current has only one path to take. The current is the same through each resistor. The total resistance of the circuit is found by simply adding up the resistance value of the individual resistors. So, as you can see at the picture, sa left side, yun yung series circuit natin. Naka-series siya. While a parallel circuit is a circuit in which the resistors are arranged with their heads connected together and their tails connected together. The current in the parallel circuit breaks up, with some flowing along each parallel branch and recombining when the branches meet again. The voltage across each resistor in parallel is the same. Dito naman sa parallel, ayan na sa right side, ma-appreciate naman natin yung parallel. Series circuit. Here are the important traits we need to understand in series circuit. First is the current. The amount of current is the same through any components in a series circuit. Sabi nga din sa formula, I total is equal to I1 is equal to I2 is equal to and so on and so forth. So, ang ibig sabihin lang, yung amount ng current na dumadaan sa bawat resistor ay equal. Series circuit. Here are the important traits we need to understand in series circuit. First is the current. The amount of current is same through any component in a series circuit. Sabi nga dito sa formula, I total is equal to I1 is equal to I2 is equal to I3, so on and so forth. Ang ibig sabihin lang, yung amount ng current na dumadaan sa bawat resistor ay equal lang silang lahat or iisa lang. So, ito lang ang ibig sabihin nun. Importante to kasi kapag hindi mo alam yung na equal lang yung current ng series circuit, mahirapan ka mag-solve ng mga problems. Next naman tong resistance. the total resistance of any circuit is equal to the sum of the individual resistance. So dito naman sa resistance, yung total resistance ng isang current is pinag-add lang na resistance ng bawat resistor. Basta pag-a-add mo lang yung resistance ng each resistor to solve for the total resistance. Yung formula nga dito is R total is equal to R1 plus R2 plus R3 plus Rn. So, ganun lang siya. Pagkuha ng resistance. Total resistance. Last is voltage. The supply voltage in a series circuit is equal to the sum of the individual voltage drops. So, ganun lang din siya sa may resistance. Bali, B total is equal to B1 plus B2 plus B3 plus Bn. Yung formula nito. Pwede rin i-apply na agad dito yung Ohm's law na B is equal to I times R. Since equal naman yung current, pwedeng ganito na yung formula na gamitin. B is equal to I times R1 plus R2 plus R3 plus Rn. So, ganun lang dito sa series circuit. Mahalaga lang itong mga to, kaya mga dapat tatandaan para masolve ng tama yung mga problem natin. Para mas maintindihan pa, meron tayong ditong sample problem. As you can see sa picture, yung circuit natin ay nakaseries. Yan, isa lang yung daloy ng current. Sabi sa problem, we need to find the total resistance, find the current, and find the voltage across the 10 ohms resistor. So, yung mga given dito ay R1 is equal to 20 ohms, R2 is equal to 10 ohms, and R3 is equal to 40 ohms. Then, yung voltage niya is 12 volts. Una muna nating hahanapin yung total resistance niya or yung R total niya. Pagplasin lang din natin yung mga lahat ng resistance kasi nakaseries siya. So, 20 plus 10 plus 40 ohms. Ang makukuha nating sagot ay 70. Which means yung R total natin ay 70 ohms. Next naman yung current. So, the current can be calculated using the Ohm's law. Yun yung I is equal to B over R total. Magiging 12 volts over 70 ohms siya. This is equal to 0.1714 amperes. Therefore, yung total current natin ng circuit natin is 0.1714 amperes. Ganun lang din yung amount ng current ng I1, I2, at I3 natin. So, next naman yung voltage across 10 ohms resistor. So, R2 yung resistor na may 10 ohms. So, para makuha yon, apply lang natin yung Ohm's law. Ang formula natin doon is B2 is equal to I2 times R squared. So, yung I2 natin na 0.1714 na nakuha kanina, times lang natin sa R2 natin na 10 ohms. Ang makukuha sagot natin ay 1.714 volts. Therefore, yung 1.714 volts, yun yung nandun sa resistor na may 10 ohms. Parallel circuit. Here are the important traits we need to know about parallel circuit. Let's start with the voltage. Voltage is equal across all components in a parallel circuit. So, unlike sa series, itong parallel circuit, ang equal ng amount na dumadali sa buong circuit ay yung voltage. So, tulad nga ng sabi sa formula, B total is equal to B1 is equal to B2 is equal to B3 is equal to Bn. Ganun lang yun. Kailangan lang tatandaan. Next naman yung current. The total circuit is equal to the sum of the individual branch current. So, dito naman, hindi equal yung current ng bawat resistor gaya nung sa series. Para mas madaling tatandaan, nagkabaliktad lang ng traits itong parallel at series sa current at voltage. So, babalik tayo sa current ng parallel. Yung total current is yung pinag-add lang na current 1, current 2, current 3, current n. Yung formula nito ay I total is equal to I1 plus I2 plus I3 plus In. Pwede rin ditong i-apply syempre yung Ohm's Law para mas madali. Then, if given yung values, syempre. So I total is equal to B times 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. Lastly, yung resistance naman. Individual resistances individual resistances diminish to equal a smaller total resistance rather than add to make a total. Dito naman, hindi sila parehas nung series sa pagkuha ng total resistance. Kapag 2 resistances lang given, pwede siya masolve sa formula na R total is equal to R1 times R2 over R1 and R2. Kapag naman more than 2 resistance yung given sa circuit, masasolve natin siya using the formula 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn. So, yan yung mga importanteng malaman at intindihin para sa parallel circuit. So, to further understand the parallel circuit, meron siyempre tayong example. Makikita naman sa picture na naka-parallel circuit siya. Ang hinahanap is yung total resistance ng circuit. So, substitute lang siya sa formula yung mga given values. Ang makukuha nating sagot sa kanya, total resistance niya is 500 ohms. So, ayun na nga. Dito na nagtatapos yung presentation ko sa Electrical Engineering 2nd Sem Midterm Coverage. So, thank you sa pakikinig. Stay safe and God bless.